Good evening. It is IN7, which is linear inequalities. And solving an inequality means finding the values of the variable that make the inequality true. So in other words, solve each inequality the same way you solve an equation. It's exactly the same way. However, instead of having an equation, an equal sign, for example, 3 plus n equals 7, okay? Instead of the equal sign, we are going to place one of these inequalities, okay? Meaning that it could be less than, it could be greater than, it could be less than or equal to. That's what this line below the less than sign is. Or you could have greater than or equal to, okay? And we'll talk a little bit further about what exactly those particulars mean. What I want you to do is go ahead and hit pause and copy down this information. Alright, so again, now that you understand that it's the same way as an equation, except we're not going to place an equal sign in here. We are going to place an inequality. Okay, for example, less than or equal to. So we have to, the value of n could represent many numbers. Okay, it just has to, once it's added to 3, it has to be equal to 7 or less than. Okay, so for example, if we put 4 in here, 3 plus 4 equals 7, but it cannot be 5 because 5 plus 3 would be 8, which would be greater than 7. So this could equal 4 or less. Okay. Now we'll talk a little bit further once I'm kind of jumping ahead just a little bit. So hopefully that that makes a little bit of sense to you. We will talk further about it in these next few slides. So let's go ahead and solve this equation first. Okay. So we're going to use our equation rules again. So since it is adding 5, we are going to do the opposite, which is adding a negative 5 to both sides of the equation. And again, when we say both sides, we're talking about where that inequality or the equal sign separates. One side, that would be the left side, the other side would be the right side. And that's what we're comparing. So since we're a positive 5, we're going to add a negative 5 to both sides. 5 plus a negative 5 again is 0, which makes it x by itself, and it is less than or equal to, make sure you bring it straight down, 18 plus a negative 5, different signs means you're going to subtract, and we get 13, and 18 is bigger, so it's going to stay positive. So my answer to this again is x is less than or equal to 13. Okay, it has to be less than 13 or equal to that number. So if we were to write it on, for example, a number line, okay, and we put our number 13 here, okay, 0 would be down here. And again, we read it left to right, so x is less than or equal to 13. Less than or equal to, because it can include the 13, we circle it, we fill in the circle, and it would be anything, and then we draw a line and fill it in 13 or smaller. Okay, that's how you would actually graph that on a number line. Okay, so let's look at the next one. This is now 15 is greater than y plus 4. So again, we start on the side with a variable, adding 4, so it's adding a negative 4 to both sides. Y, bring down the greater than sign, and unlike signs, you subtract once again. We get 11. 15 is larger, so it's positive. Now if we were to graph this on a number line, okay, and we have to start with the variable, okay, and say y is less than 11, or you can say 11 is greater than y. So you can look at it either way. Again, this point right here is 11. This point is 0. Okay, and it says y is less than 11. And so when you plot it, you actually make a circle around it, not filling it in, because it does not include 11. It says y is less than 11. Okay, so it cannot equal 11. It has to be smaller than that. And then we would draw a line. Okay, and it's a little hard for me to do on here, so I apologize. But you make it a little bit heavier line from that point, and you leave it as an open circle because it does not include the 11. Okay, let's look at the next one. Now it is a multiplication problem. It says 81 is less than or equal to 9 times W. So do the inverse operation, which again is dividing, since it says multiply. Divide by the same number, because we're trying to make this again into a positive 1, so that 1 times W will give us W, and it is the less than or equal to sign, and 81 divided by 9 is 9. Okay, so now we can look at my number line. We've got 9, and we've got 0, and it says W will be greater than or equal to 9. So since it is and does include the 9, since it's equal to it, but it says that it's greater than, then we draw a heavier line and know that it's any number that's a 9 or larger will make this inequality hold true. Okay? Next problem. It is m minus a negative 1 is greater than 7. Okay? So again, my suggestion is change this into an addition problem. M, change it to addition, opposite of the second number, which is a positive 1, greater than 7. So now we can do the inverse, which this would be a negative 1. Negative 1 to both sides. M is greater than, these are different signs, so you're going to subtract, and we get 6. 7's larger, so it's positive. So M is greater than 6. So here's my 6, here's my 0. It does not include the 6. So we draw an open circle, and then our line saying that it is larger than 6, but not including the 6. We'll make the sentence true. Okay? Questions on that? Please make certain that you make any notes of that in your notebook, and we can discuss them further tomorrow. Just keep in mind that it is exactly the same way as solving an equation, except we have the inequality signs listed. Do take note on the assignment. They won't ask you to do this. This is something that I like to show students. Gives you a little bit more of a visual of as far as what they are asking and what this is stating. This is the correct way of graphing it, but they do not require you to graph it on homework today. Have a great night.